This video is going to cover what electrolysis is and some common questions associated with it at National 5 level. The definition of electrolysis is separating ionic compounds into its corresponding elements or ions using electricity. Note that we will only form two ions, one positive and one negative, and some information you've learned previously that helps here is that metals always form positive ions, non-metals form negative ions. So that will be useful later on. Electrodes are a term mentioned here quite a bit throughout. They are a piece of apparatus used in electrolysis, and we always use graphite rods, so carbon in the form of graphite. You've discussed graphite before when you looked at covalent networks. We use graphite because it's unreactive, so it won't interrupt the experiment at all. It's insoluble, so it won't dissolve in the solution, and it can conduct electricity, which is important to let the electricity pass through the solution. So here is the diagram. You can ignore the notes round about it for now, but you will be expected to be able to draw this diagram with the labels. So all you would need to label is the power supply. I tend to just draw it in the box, but it doesn't really matter. These lines are wires. Now we don't label wires. We have electrodes. I tend to just put the negative and positive signs. It can go to either side, it won't matter. If it's already drawn for you, it would be identified which is positive and which is negative. In the classroom, you would know because there are two parts to the power supply where you can plug your wires in. One side is positive, one is negative, and that would link in to this section here. These parts here are the carbon graphite electrodes, and we would have a beaker containing an ionic solution, so a solution which has metal and non-metal compound dissolved in water. Now I've put some information round about this diagram to help us answer some questions. So a common question is, why do we use a DC power supply, so a direct current power supply? The reason being, it makes sure the electricity flows in one direction, and that ensures one product forms at each electrode. If it was alternating, then you might get a mixture at each side, so we wouldn't want that. So the idea of electrolysis is to separate it. So how to decide which element forms at each electrode? So we've learned before that your non-metal is a negative ion. So because opposites attract, the non-metal ion will always be attracted to the positive electrodes. So the negative attracts to the positive. So it would form on this side. What you would see every time with your non-metals is bubbles of gas would form round about there. So you would see that in the class better. On the negative electrodes, you would get your metal ion forming because metal was positive, so it's attracted to the negative electrode. This would form as a solid. Depends on the metal what colour that would be, so it's enough to just say solid. Now, I have just left this as a generic diagram. You could get asked which specific non-metal and metal depending on which ionic solution is used. So the bottom section here is how to decide which element at each side based on a specific ionic solution. So if we take copper 2 chloride first, copper, sometimes it can help to just decide its symbol for quickness, is Cu, chlorine is Cl, copper is the metal, chlorine is the non-metal. Using our rules from previously, copper is a positive ion because it's a metal, chlorine is a negative ion, so the copper would form at the negative electrode as a solid. The chlorine is a negative ion, so would form at the positive electrode as bubbles. And you would be able to collect that gas or smell it because it's chlorine. You would easily be able to smell the chlorine gas. So let's take potassium oxide, same idea. So potassium, K, oxygen, O. Potassium's a metal. You would use your data book to decide metal or non-metal. So remember, you've got your staircase. The metals are on the left of the staircase and the non-metals are on the right. So that's some key information you would need to be able to work this out. So potassium is on the left of the staircase, so is a metal. That would make it a positive ion and therefore would form at the negative electrode. Whereas oxygen, you're assuming it's the opposite, but double check. Oxygen you'll find on the right of the staircase, which is a non-metal. It would be a negative ion. Now, if you want to be even more specific, it would be an ion with a 2 negative charge, based on what we've learned about valency and ionic charge. But it's not asking you that just now, so it wouldn't really matter. So non-metal, therefore, forms at the positive electrode. So as long as you can remember that metals make positive ions, non-metals make negative ions, and they are attracted to the opposite electrode, you've pretty much answered it. Another piece is, what would you observe at each electrode? You wouldn't observe potassium metal because you can't see that it is specifically potassium, but you would see a solid. Same with the non-metal, you would observe bubbles of gases there. You wouldn't observe oxygen because you can't tell that by looking at it. You would need to test that further. So hopefully that will let you answer any specific questions with electrolysis. We can take things a wee bit further later on, but for now that is enough information for you.